Does KFC mutate their chicken? No. At least, I don't think so. But should they? That is the question that has been asked since the beginning of time. And to find the answer, we first need to explore genetic algorithms. And I know what you're thinking.
What the fuck is a genetic algorithm?
And it's actually pretty simple. Genetic algorithm is essentially just another word for evolution, because us programmers like to pretend that we're smart. But how do you simulate evolution? It's actually not as hard as you might think. You start off by just creating a creature. In this example, the creature is a chicken. Then you make an obstacle that the chicken has to get past. In this example, the obstacle is a road that needs to be crossed. At the start, the chicken just does things randomly, but then later on, you reward it when it does something good, and you punish it when it does something bad. Then, once the chicken has babies, it will tell its children how to get rewards and how to avoid punishment. Now, the thing that always confused me when I was first learning about genetic algorithms is how you reward and punish a computer. Obviously, computers can't actually be punished or rewarded, so the most common method is by using a single value, which is often referred to as fitness. Fitness often just determines how successful the creature will be at reproducing.
And he has nice abs and he's a beautiful guy. Are we gonna double like his picture? Of course we are.
And is often calculated by just adding up the punishments and rewards. In order to illustrate what I'm talking about, I decided to write a little program. This is essentially a genetic algorithm in its most basic form. For every 1 that the list contains, the computer is rewarded, adding 1 to the fitness value. For every 0, the computer is punished, minusing 1 from the fitness value. Although it may look like there's only 1 list and 1 fitness value, there are actually hundreds running at the same time, and that's what makes this program able to learn. The way that this program works is actually very similar to the example I gave earlier. You start off with 500 chickens, all containing random numbers. Then, you assign each chicken a fitness value, based on how many zeros and how many ones it has. Now, once you've assigned each chicken with a fitness value, you add its characteristics to a pool a certain amount of times determined by its fitness score, the characteristics being the chicken's list of numbers. For example, our previous chicken had a fitness score of 4, so we'd add its list of characteristics to the pool 4 times. Once the pool has been generated successfully, you create a new batch of chickens. But instead of just generating characteristics randomly, you randomly select one of the lists from the pool and assign it to the chicken. This whole process means that the higher a chicken's fitness score is, the better the chance of it being duplicated for the next generation is. There is one last step though. If you perfectly duplicate the chicken's characteristics every generation, that just means that you're relying on the first initial batch to have at least 1 completely successful chicken, because without some form of variation, they can never improve. So the last step is adding a mutation. Adding mutation is actually really simple though. You just randomly select a random characteristic and randomly change the value of said characteristic. Like this.